Hi everyone, in this video we're going to talk about deductive reasoning. Okay, we're going to show you some examples of how to identify when you're looking at deductive reasoning and the different laws we're going to talk about. In the previous example, or the previous video, we spoke about inductive reasoning, which was based on patterns and observations. Deductive reasoning is based on rules, facts, and definitions. This is something that's concrete and that there's actual evidence for, not something that you're making an assumption on. So the two rules that we're going to be using are the law of detachment and the law of syllogism. Okay, I'll go over the rules here in a little bit for both, but the symbol representation for them, for detachment, says if P is given and it's true, then it implies R is true. And Q is true. And for syllogism, we're going to be given if P is true, then Q is true. And if Q is true, then R is true. Therefore, P implies R. So law of syllogism, we'll go over some examples over that, but it has multiple levels or steps to get to draw a conclusion. Unlike detachment, we just use one statement. So let's talk about the law of detachment. If you see here, we have this statement right here. What it really means and what it's saying is if a statement P implies Q is true, then if P happens, then Q must be true. Okay, this arrow here means implies, or it can also mean therefore, or it can mean implies. So if P, then Q. So here we have a situation. If I am late to school, then I need to get a tardy pass. This morning I got to school at 9:10 a.m. What conclusion can I draw? So what I like to do is I like to identify my statements and label them as P and Q. So I'm going to label the first statement right after the if. That first part is going to be the P section. This is P. And the second part is Q. I'll do this in red. So right after the if, we label that as if P. And right after the then, we label that part as Q. Okay? Now when I look at the next statement here below, this morning I got to school at 9:10 a.m. Which one of those does it apply to? The letter P or the letter Q? Notice how 9:10 a.m. is the letter P. You're late to school. So this statement is P. I can then conclude that I will need a tardy pass. Okay, I can go from P to Q. If this morning I got to school at 9:10 a.m., then I will conclude that I will need to get a tardy pass. Notice how we're not going from Q to P. We're not going the other way around. We're not saying if Q happens, then P must be true. We're not saying I got a tardy pass, then that means I got late to school. If you got a tardy pass, there's many reasons why you got a tardy pass. Maybe you were walking around the halls. Maybe you were talking to your friends. I mean, there's a lot of reasons why you got a tardy pass, right? So the law of detachment is true when you follow this deduction. Okay, we have if P, then Q, not the other way around. Q cannot imply P. It will not always be true. Here's a math statement or a math example. So if a figure is a square, then it's a polygon. I know figure A is a polygon. Here's the example that I want to show you, right? So this section here is P. It's highlighted P. Then it's a polygon is red. This is Q. Now I'm given the statement, right? When I look at the statement below the given, I want to identify what is it that I'm given, right? I'm given here figure A is a polygon. Is that P or is that Q? Figure A is a polygon is Q. So I'm going to label it as Q. And my conclusion here is figure A is a square. If I look up here, figure A is a square is P. Can I conclude Q to P? Absolutely not. And when that happens, we say that this is an invalid statement or a false statement. Right? You cannot imply that because you have a polygon, then it's a square. It could be a pentagon, it could be a hexagon, it could be a diamond, it could be a circle, it could be anything that is not a square. So Q does not imply P. This would be false. Let's talk about the law of syllogism. So law of syllogism is like the law of detachment, except that we have another layer to it. It's an extra step. And if you look at the rule here, we have if P, then Q, and if Q is true, then R must be true, right? So we can imply P is R. P implies R as a true statement. The way I like to think about this is the domino effect, right? I have a domino that causes the second domino to fall. And if the second domino makes the third one fall, then the first domino made the last domino fall, right? It's the law of syllogism. There's multiple ifs and thens here. There's two ifs and there's two thens as well. So let's check it out. If there is a power outage, then the freezer will not work. If the freezer does not work, then the ice cream will melt. I'm going to label them as P, Q, and R statements. If you prefer other letters like A, B, C, or D, E, F, as long as you go in alphabetical order, it should be okay, so that you don't confuse the order of the statements. So if there's a power outage, that's P, then the freezer will not work. That's Q. And then I'm going to say that if the freezer does not work, we repeat Q. Freezer doesn't work, and then something else will happen as a result. Then the ice cream will melt. And that's going to be R. So there's multiple things happening here, right? There's a power outage, then the freezer's not going to work. If the freezer doesn't work, then we don't have ice cream because it's melting. Okay, P, Q, Q, R. There is power outage. When I look at what I'm given here, I can tell that the power outage is the letter P. That's the original statement, right? What can I conclude? I can actually just go ahead and ignore Q, and I can say P implies R. If there's a power outage, then the ice cream will melt. I misspelled ice cream because I was thinking about a joke. So, let's see. Yeah, so we're going from P and we conclude R. This is what we're trying to say with the law of syllogism. Q is not going to be included because it's assumed, right? If there's no power, then at the end we're going to have our ice cream melting as a result. So Q is not necessary to be said. We just go from P to R. So now let's try a math example. Feel free to pause this and give it a try to see if you get the same solution as I do. So if a polygon is a rhombus, we're going to call this P. If a polygon is a rhombus, then it is a parallelogram. It's going to be Q. If the polygon is a parallelogram, right, I'm repeating this statement, so I'm saying Q again. Then its opposite angles are congruent. That's R. Now, we will talk about this topic much later in class, so you don't even have to know what any of this means. You don't have to know what a rhombus is or a parallelogram or opposite angles being congruent. We don't have to know any of this information. What we want to focus on when we're thinking about logic is follow the process, follow the rules. Here I'm given below, polygon A is a rhombus. That right there is which of these letters, right? We have P, we have Q, and we have R. If you look at it, polygon A is a rhombus is the letter P. So I'm going to classify this as P. Can I conclude that the polygon has congruent opposite angles? Can I conclude this from this statement? Well, I'm going to ignore Q and go straight from P to R. Its opposite angles are congruent, and that is what it's saying. So yes, this is true. Or if you want to say valid, because we're going from P to R. We're skipping Q altogether, and we're concluding if you have a rhombus, then the angles are going to be congruent. The opposite angles are congruent. Let's put it all together, right? So how do we tell them apart? We have the law of detachment and we have the law of syllogism. The law of detachment has only two statements, an if and a then. That's all you're working with, okay? So we have a P goes to Q. Notice how there's only one if, which we have here, an if statement, and then one then statement. Detachment has only two things to compare. Syllogism has multiple. Right? If you look at syllogism, we have if a number is divisible by 10, then it's divisible by 2. If it's divisible by 2, then it's an even number. Right? There's multiple layers to this, and that's why we have P, Q, and R. So P implies Q, Q implies R. Therefore, we can say P is going to imply R. We can skip Q altogether and say P implies R. So syllogism is the domino effect that causes a ripple, right? One makes the other one fall, which makes the last one fall. So the first domino makes the last one fall. And then detachment is simply just one given statement to another. I hope this has helped. Let me know if you have any questions. Don't forget to subscribe if you haven't already. And as always, we'll calculate later.